Alright, hi everyone, welcome to yet another contest screencast. Today I will be attempting Codeforces round 727 Div2. So yeah, and like I lost candidate master in the last round, so I think I will be needing a plus 11 right now to get back to candidate master. So yeah, that will be the aim for this contest. And I hope it is getting recorded and yeah, the sound is fine as well. Also, is this like a Div1 plus Div2 round? Because I see like Tourist is also participating. I mean, he has registered, but yeah, maybe he does not participate. Uh, so yeah, let's see. And let me check if Sublime is working fine. Yeah, seems like. So here we go. Problem A, there are n people participating in some contest. They start participating in x minutes intervals. That means the first participant starts at 0. Alright, during a contest, duration of a contest is t minutes for each participant. So the first participant finishes the contest at time t. Okay. The second at time t plus x, and so on. What do they mean by this? The first participant starts at 0. The second at time, okay. When a participant finishes the contest, their dissatisfaction value equals the number of participants that started the contest but haven't finished yet. Okay. I don't understand what do they mean by this. In the first example, the first participant starts at 0 and finishes at time 5. By that time, the second and the third participant start, so the dissatisfaction value is. Oh, all right, cool. So, what do they want exactly? Three integers n, x, and t, and determine the sum of dissatisfaction values. Okay. So we have. Let's keep this k. Right. So for every participant, we need to note down the number of participants that have started yet. Right. Okay. So the dissatisfaction value equals. So the first participant finishes at time t, and how many other participants have started? It is like x, 2x, and all of them, right? So if I know that three people are able to start before this one, so what about 2t? Okay, this one finishes at t plus x, right? This is pretty confusing. And finishes at time 5. The second participant starts at time 2 and finishes at time 5. By that time, the third and the fourth participant start. Okay. Starts at 4 and finishes at time 9. Okay, so for each of them, it is coming out to be same, right? The fourth participant starts at 6 and finishes at 11. Okay. So for the last one, you are the one starting, that is fine. For the second last, you start at X, but then T plus K times X. Right, so if T is less than X, like here, so they haven't given a case where T is less than X. If T is less than X, then obviously it does not matter. So C out 0. So dissatisfaction equals the number of participants that started the contest or starting it now but haven't finished it yet, right? So that will be T by X, right? So T by X, right? These many participants we can include. So this is like T by X, T by X. So for the first one, okay. If the number of participants is less than T by X, then all of them will be starting, right? So I have n minus 1, n minus 2, n minus 3, so on. Whenever I get T by X, alright. This is pretty confusing. Okay. So yeah, T by X. Okay. Okay, this is fine. So if this is greater than or equal to, right? Apart from that, else you have LL answer 1 equals to T by X, and then you do so you will be having right, and then you have LL answer 2. So you have like So from first till n minus 1. Right, apart from that, this will be into first. Right, so let's see. Okay, I'm getting 9 for the first one. So I have 1. How am I getting 9 here? First is 2. And then you have, alright, this should be n minus 1 minus first. Right, this seems fine now. If t is already less than x, then the answer is 0. All of them will be coming after. But also if first is greater than equal to n minus 1, then everyone will be coming in. So that started the contest, finishes the contest. Okay, when they finish, right? Otherwise you have you add the answer till here, and yeah, this seems fine. I'm submitting this now. Okay, cool. So this was not at all easy. I don't know, it was like really hard to understand first of all, and yeah, the implementation was also like not at all trivial, I would say. Once wrote a Sandler song and shared it. The song is a string consisting of lowercase English letters. Made up Q questions about the song. Q questions. Okay. Each question is about a subsegment of the song starting from the lth to the rth letter. From characters on this repeats. Okay. Considers a substring made up from characters on this segment, and repeats each letter in the subsegment k times, where k is the index of the corresponding letter in the alphabet. For example, if the question is about the substring, repeats letter A once, each of B twice, and letter C thrice, so that the resulting string becomes this. Its length is 10. About the length of the resulting string. Okay. So can I just store the occurrences of each of the letters in that string, because I think I can do that. This does not seem hard actually. So I have, let's make this t only. I have n comma q. Alright. So I'm sort of storing prefix sums here. So if s at I minus a equals to j, and here equals to 0, and rev equals to occat j comma, but if I minus 1 does not exist, then it should be 0. Occat j comma I equals to what? Equals to, right, So I have int sum 2 equals to right, I comma r plus equals to I plus 1. So let's see. Okay, this should have been, there are no test cases here, right? So 4, 7, 11 is right. 5, 4, 1, 5. Okay, fine. Checking this last test case. 82, 125, 9, 191. Okay, this is fine. Okay, cool. So this was like an easy problem. I think it was easier than A. Right, so let's go for problem C. Oh my god. Look at this. There are n students numbered from 1 to n. The level of the ith student is ai. You need to split the students into stable groups. A group of students is called stable if in the sorted array of their levels, no two neighboring elements differ by more than x. Okay, for example, if x equals to 4, then the group with levels. How is this stable? Yeah, it is stable, right? Apart from the n given students, teachers can invite at most k additional students with arbitrary levels. Find the minimum number of stable groups teacher can form from all students, including the newly admitted and newly invited. Okay. Minimum number of stable groups. Okay, so you need to fit in as many people into a group as possible, right? For example, if there are two students with levels 1 and 5, x equals to 2, and then you can invite two new students with level 3 and put, all right, cool. So all of these are till 10 to the power 18. So I don't know if there can be some overflows as well. Okay, so first of all, I think I need to sort all these numbers. I mean, without sorting, it does not make any sense. Alright, so I have int n comma. Rather, let's take all of them as long only. Right. Right. So now we have them sorted. So we need to invite k students for sure. Now the thing is, like, you don't even know how many people to include between other two people. So like, if I have 1 and let's say 9, and the difference is 4 and I need to include greater than equal to 1, then I'm done with a single person. But if I want to include both of them into one of them, I mean into one group, then what do I need to do? So for each of this pair, I think I can store the number of people I will have to insert in between, right? This is the very first thing that I can do. So right, so this will be of size n-1, right? Cool. So first of all, if n equals to 1, then you simply print out 0. I mean 1. Rather continue, because I don't want to get into that. So x here equals to arr at I plus 1 minus arr at I, right? So this is the actual difference. Now if this difference is greater than x, for example, if we have 1 and 6 and I need the difference to be 2, so I have 5, right, as the difference. So I will be needing 2 more elements. So if I have here 1 and 6 and I want the difference to be 2, so I can insert 3 and 5, right? Similarly, if I wanted the difference to be 3, then what I can do is I can do 1, 4 and 6. So that's like the floor value of the difference. So at I equals to x here divided by x, right? And x is greater than 1. So let's see this. And debug ARR. Right. Is there some other issue here? Okay. Okay, I understand. This should be n-1. So we have 1, 1, 5, 8. Okay. So here the requirement is 0. Then the requirement is 1. Then the requirement is 1 again. Okay. It should be -1, right? So if you consider, if we want the difference to be 1, then here I will have to insert 4 elements, but I actually don't have to insert 4 elements. I have to insert 3 elements. Right, yeah. Okay, if I had 1 and 7 and I need the difference to be 2, then I can insert 3 and 5, right? But if this was 8, then I can insert 3, 5 and 7 again. 7 minus 2 by 2, right? Yeah. Here equals to 0. Else what do? X here minus So here it says it requires 2 elements. But why would you require 2 elements? Like n, x and t it is, right? N, k and x, right? So required at I equals to val so x here equals to 4, 4 minus 2, 4 minus 3 in fact. Okay, this was divided by x. So here we require 1 element, here we require 0, right? Here we require another 1 element, then 0, then 2 it says. So here the difference is 7. Now if I just insert 1 element, let's say 14, 15, 16. 16 will not do it because then you will have to insert it again. But what if this was 19? There should be 1, right? Then if this was 19, okay, coming out to be 1 only. So this is fine. I mean, this was something else, right? Yeah, 20. So these are the requirement values. If the whole requirement is less than equal to k, oh, all right. So I think it would be always better to first of all, greedily merge two parts when the difference is less, right? Yeah. Yeah, this should do it. So right, if I is less than equal to k, then you do k minus equals to I, and what else do? You do answer plus plus. Otherwise you will have to have those values, right? Answer minus minus. Okay, the answer is coming out to be 2 here. I hope it is all fine. Alright, 3. So let me just check my code. I think it is fine. Okay, cool. Okay, so D problem does not have a solution yet. Like, I mean, yeah, but going for D would be the best here. Okay, so this problem was like solved in the first 10 minutes itself. Let's see what the problem is. So, is the most economical girl in Moscow. So, when her dad asks her to buy some food for a trip to the country, also like there is 1 hour 30 minutes left, so I should be giving in 100% to this problem now. So, when her dad asks her to buy some food for a trip to the country, she goes to the best store, price fixed. The store has an infinite number of items of every product. All products have the same price, 2 rubles per item. For every product I, there is a discount for experienced buyers. If you buy BI items of product, and for all future purchases of the ith product, there is a 50% discount. So you can buy an item of the ith product for 1 rupee. The store has an infinite number of items of every product. All items have the same price, right? For every product I, there is a discount for experienced buyers. If you buy BI items of products, okay, in overall, right. Lena needs to buy N products. She must purchase at least AI items of the product I. Help Lena to calculate the minimum amount of money she needs to spend if she optimally chooses the order of purchasing. Alright. Okay, so first of all, I think I should be taking in the input. Okay. So let's say we don't get any discount, then what will happen? Then the answer will be simply like the sum of all these into 2, right? Okay, so let's say I sort them all by their BI values. Then what happens? So after sorting by BI, I will have my values like A1, B1, A2, B2, A3, B3, so on up till A and Bn. So now alright, so this simply means that all of these values here, like all of these A values, you know, their price will become 50% if I am able to buy B3 in overall, right? So their price becomes 50% if I buy B3. So if I consider each of these items independently, what happens here is I have like 10 to the power 14 such elements, and each of them has a value of bi, right? So now I can sort them by bi. So let's say I have a1 still here, and then I have a b1 value, right? And then I have a2 still here, and then I have a b2 value. So the thing is, let's say I decide that till this point, you know, till this point I will pick them all up, like till from all the suffix I will pick them all up, right? And then I mean, picking up any ball does not harm me at all. Like if I have these balls whose, I mean, consider them as balls. If I have all these balls whose b value is b1, which is the smallest, then I might as well pick up a ball from here or here. Now it would obviously be better to pick up a ball from this side. Why? Because if I pick up a ball from here, then all these balls already have, like, consider b value as a deadline. So I mean, not even a deadline, but all of these balls here already have a bi value higher, right? So the chances of them getting a discount is lesser compared to this ball, right? So the thing is, why should you waste the balls that have a lesser value of that have a lesser bi value? Why should you waste them? That is the thing. So I think if you decide that from a certain b value, let's say I say x, okay? So I want to pick x balls. So which x balls should I pick? I will be picking up the balls that are in the suffix, right? I mean, considering that greedy property, I haven't proved it, but it seems correct. So I will be picking up x balls from the suffix. So can I even do a ternary search on this? I mean, if I decide to pick up x balls from here, or can I do a binary search that, let's say I want x balls whose price should be halved. So what do I do for this x? I exclude this x balls and I consider the suffix, okay? Now I see how many balls are left. I buy them all for a price of 2, right? I think I can do a binary search on that. I buy all of them with a price of 2, and then then I just check that the number of balls that I have bought here, are they greater than the current this BI value? Can I do that? So if they are greater, then obviously I can ask for X free balls. But let's say it tells me that I am not able to buy so many balls here. So that simply means I need to decrease my X. And if I can, then I need to increase my X, right? Yeah, I can do a binary search on this, and I will be picking up balls only from the suffix. So what do I do? First of all, I sort them. So sorting on the basis of the second right. So the thing is that they've only provided 2 test cases here. Right, and I need to take in the sum as well. And then sum equals to 0 and plus equals to ARRI dot FF, right? Cool. So if it is possible, okay, first of all, all right, and then I have so if this is equal to 0, then you obviously return true, right? So just to be safe, I am putting this. Cout answer plus sum minus answer into 2. Right, yeah. So here, how do I tackle this? Right. If val is greater than equal to I, Okay, so I do rem minus equals to, so I will be needing the sum as well, right? So here, if sum, sorry, if rem is greater than equal to what v at index dot ss. So here you are selecting the first ball. So like val minus equals to I, rem minus equals to I, that is fine. Index equals to I. Instead, let's do this. So let's see. And I need to pass in the sum variable as well. I am already doing that. B was not declared. Okay, we have to pass in ARR. Okay, this should be. So it is giving the answer as 10. Okay. Debug answer. It gives the answer as 0. Okay. Oh, this should have been v at I dot ff. Alright. Oh, this should have been like this. So let's see. Debug val, debug rem, and debug what? Debug. So this should be here. So I have val 2 remaining equals to 3. This is fine. So then I have val 1 and remaining equals to 4. So, okay, this should have been a break statement here. So I'm getting 9 now. Of product 2. So why am I not able to get 2 here? So if I have this 2, alright. So remaining equals to 3. I buy this for 2, I buy this for 2 again, and I buy this for 2. And then I'm able to buy this for 1. Right. Okay. So if I say that I want to buy X of them, then I save these X, and all the others I buy for 2. Right, yeah. So this is not just that. Bought equals to sum minus rem. In fact, it is rem, right? So these are the items that I've already bought. Right. So this should have been v at I dot. So I don't need this index actually. Right, I have okay. Alright, in fact I do need that index. Okay, index equals to okay, here the index should be here, right? So if v at I dot ss is greater than bot, right? Else you do dot plus equals to v at I dot ss. Okay, so it was val2. Val2 is working fine. 4 did not work. 3 also did not work. So let's test it with this input. So it is giving the answer as 10. Okay. Answer was 6. So I have 1, 2, 2 and 1. Right. So I need to print the index as well. 0, 1, 2, 3. Right. So here how many did I buy? I bought 1. So val is 6, index is 3, bot is 2, then okay, bot is 4. So here when bot was 4, okay, let's call possible ARR end. Let's call it for 6 and let's see what is the issue that we're having. Right, so you have index as 3, v at I dot ss equals to 2, right? And how much is bought? Oh yeah, you bought 2, right? Yeah. So then the bought value is 2, 4 is fine. Okay, so you've bought these 2. This should have been plus ff. Oh, yeah, now it seems to be fine. Okay, let's test it with this one again. Yeah, seems to be fine. Okay, cool. 288 is not bad. And like path is performing really well today. Great. I don't know, maybe there is some greedy solution to this as well. Because thinking about this binary search and then implementing it again is not at all trivial. Alright, then maybe I can try out E problem. Also, I don't know if people are able to hack solutions. Okay, I'm at least locking this D problem to see what people are doing. Oh, he's done that binary search too. Nice. Oh, actually, he's not doing a binary search here. He's doing something else. Oh, nice. And how much time did my code take to run? Yeah, 77 milliseconds is fine. Okay, let's look at problem E then. With number 0 in the left hand and 1 in the right hand. In the ith question, Alice asks Bob to replace a card in the left or right hand with a card with number ki. Oh, alright. Bob can answer all requests. If it is possible, find a way to do it. First of all, let's look at the people who've solved both of these problems. Okay. So yeah, both are like same only.